Hi, today we're going to continue talking about section 3.1. So far in section 3.1 we've talked about going from an equation to a graph to an equation, and now we're going to look at the slightly more complicated going from information about a graph to an equation. So this one is a little bit more challenging. On this assignment we're going to ask you to write the equation for a sinusoid. When we say the equation for a sinusoid, we just mean either a sine equation or a cosine equation. In all of these problems, you could do it either way. And in fact, there's infinitely many possible solutions in the form of a sine answer or in the form of a cosine answer. Typically, we're going to ask you for only one. And the idea would be to pick the easiest one to use. Sometimes one is easier to use than the other. And we'll talk about how you could tell which one is which. Okay. So let's look at a couple of examples here. I'll walk through these with you guys and talk through what's going on. So in this one, we want to write the equation for a sinusoid whose amplitude is 10, period is 6, and it passes through the point 3, 8. So I remember the amplitude is related to the A coefficient, because again, our job is really to find these values for A, C, H, and K. So I remember the amplitude is the same as the absolute value of A. Now, I don't know whether that A needs to be positive or negative right now, so I'm just going to write it as the absolute value of A. Remember, if I have the absolute value of A is equal to 10, A could be positive 10 or A could be negative 10. We'll talk about how we can tell which one we want to use later, because it's going to depend a little bit on what we're doing for H and for C. The period, remember, the period is 2 pi times C. So I can solve by dividing both sides by 2 pi. So the 2 and the 6 reduce to give me a 3, and the pi is still stuck there in the denominator. And again, I've written this as the absolute value of C. My suggestion for you is that in all of these problems, we're going to choose to make our C's positive. There's infinitely many answers. There's answers where C is positive. There's answers where C is negative. In my experience, it's never going to be easier making C negative, so I always just choose to make C positive and deal with everything else accordingly. I would suggest you doing the same. So now we're left with this point. It just says it has to pass through that point 3.8. It doesn't designate that point 3.8 needs to be a maximum or a minimum or a midline point. It just can be any old point 3.8. So my suggestion to you is, depending on whether you want to pick to write a sine answer or a cosine answer, I would choose to make that point negative 3.8 a different kind of point in each one. So the easiest point to make negative 3.8 if we're doing a sine function is to make it a midline point, because in the parent function, 0, 0 is a midline point. So if we make that a midline point, or a transform function point, negative 3.8, also a midline point, we know that Cx from the parent function plus h has to give us the x from the transformed function. So C times 0 plus h has to give us negative 3. And C times 0 is 0. H plus 0 is h. So that just tells me h has to be negative 3. Likewise, I know that a times the y from the parent function plus k has to give me the y from the transformed function. So just like we had before, we're going to have a times 0 plus k has to equal 8, so just k is equal to 8. And because we don't care about the type of midline point, remember there's two kinds of midline points for a sine function. So like, here's like a little piece of what the sine function looks like. So notice that we have midline points, say, here and here. This midline point goes from a minimum to a midline point to a maximum. But this midline point goes maximum, midline point, minimum. So there's two different kinds. Here it doesn't matter what kind of midline point we're using, because we can just pick these to be the same kind of midline point, which tells us that the A then has to be positive. So that's everything we need to write our sine answer. So 1 over 3 pi times x minus a negative 3 plus 8. And then if we do the cosine, let's change the color there so it'll be a little easier to follow. So in the parent function, I would use the point 0, 1, which is a maximum. And the transform function, we're going to make negative 3, 8 also a maximum. Again, because these are the same kind of extreme point, that tells me that A is positive 10. Just like before, because the x-coordinate here is 0, the h is going to be the x-coordinate in my transform function. However, here the k, or the y-coordinate in the transform function is not 0. So we have to go and solve this equation. So a times the y-coordinate from the parent function plus k has to give us the y-coordinate from the transform function. So 10 times 1 plus k has to equal 8. So if I subtract 10 from both sides, k has to be negative 2. So there's my cosine version. Now notice the sine version was a little bit easier because since the x-coordinate on the parent function was 0, the h is just going to be the x-coordinate from the transform function. And since the y-coordinate from the parent function is 0, the k is just going to be the y-coordinate from the transform function. The same thing was not completely true for cosine. The x was still the same as, or the x-coordinate from the transform function was still our h, but notice here that the y-coordinate wasn't the same as the k, and the reason is that the parent function y-coordinate was not 0. Okay, so let's do this again for a new example. This time, same conditions, the amplitude is 10. So that just tells us the absolute value of A is 10. The period is still 6, so we can still say that C is 3 over pi. Here, though, we're told that the midpoint has to be negative 3, 8. So because I see I'm dealing with a midpoint, I want to use sine, because I know then immediately the h and the k are going to be negative 3 and positive 8. And the A can just be positive because it doesn't tell us what kind of midline point it is. You could pick A to be -10, and that's still going to be a correct answer. And we're done, because it was really the same problem as before. And I wouldn't do a cosine one because that one was so easy. Here on number 3, again, we're going to start the same way. So everything is still the same, except now that we're told that our point -3/8 has to be a minimum. Since we're given an extreme point, I'm going to use cosine. So the point from the parent function I'm going to use for cosine is 0, 1. And my transform point that I have is -3/8, which is a minimum. Since the parent function is a maximum and the transform function is a minimum, it's opposite. That tells me the A value is -10. Since the x-coordinate of our parent function we're using is 0, the x-coordinate of our transform function is going to be my h. And then because my y-coordinate of my parent function is not 0, that means I'm going to have to write an equation to solve this. So the equation is a times the y-coordinate from our parent function plus k has to equal the y-coordinate from our transform function. So when I add 10 to both sides, I get that k is 18. And I would not do a sine one because that'll be even a little bit rougher. This one is easier even. So again, my amplitude, I know the A value is 10. Period tells me the C is 3 over pi. And then again, since we're doing a max or a min, an extreme point, right? Maxes and mins are extreme points. I'm going to use cosine. So the parent function there, 0, 1 is a max. And it's going to the transform function of -3/8, which is also a maximum. Because max to max is the same, tells me that the A value is +10. Again, the x-coordinate for my parent function is 0. The x-coordinate for my transform function is -3. So that tells me the h is -3. And because the y-coordinate for my parent function isn't 1, I have to write my equation. So I have A times the y-coordinate for my parent function plus k is equal to the y-coordinate for my transform function. Subtract 10 from both sides, I get that k is equal to -2. So I have y equals 10 times cosine of 1 over 3 over pi times x minus a -3 plus k, or -2. And again, I would not use sine in that case, again, because the point I'm told needs to be a max and a min. Okay, the last example here. This is the most complicated one. Here, all we're told is that we have to go, or this function has to have a maximum at 310 and a minimum at 11, -4. So I would start by kind of sketching a picture. So 310 is up here, and 11, -4 is maybe down there. You make it a little bit more to scale. So it needs to look like that. So the first thing I'm going to do is I'm going to find the value for k. because I know that the k needs to be halfway in between the minimum and maximum. So that's going to be y max plus y min divided by 2. So that's going to be 10 plus negative 4 divided by 2, which is 3. And then my k value then, or my a value, my amplitude, has to be the distance back to there. So if that's 3, and I got to get to 10, how many did I go up? It was 7, right? Or you could think about it as y max minus k. So far, so good. So notice that next thing we'll do is we'll find our c. So if I completed this graph to draw one full period, I would come out to here. So this much of my graph is half a period. And that's going to be the x. To find that length for the half of the period, I'm going to take the x-coordinate on the right and subtract from it the x-coordinate on the left. That's 11 minus 3. So 1/2 a period is 8 units. Remember that the period is 2 pi times the absolute value of c. So 1/2 times 2 is just 1. So the 2 and the 1/2 cancel each other out. So the absolute value of c is 8 over pi. And again, we're always going to choose that c to be positive. So my c is just going to be 8 over pi. And then my last thing to do is to find my value for h. We're going to do this the same way. So my parent function that I'm going to use is going to be cosine, because I know about maxes and mins. If I knew about midline points, I would use sine. But if I know about maxes and mins, I'm going to use cosine. So from the parent function, we're going to use the point 0, 1, which is a maximum. And the transform function, I'm going to use the point 3, 10, which is also a maximum. Because these are the same, that tells me the a value is positive. If I'd use the minimum, the a value would be negative. Because the x-coordinate here is 0, the x-coordinate for my transform point is going to be my h. And that's everything I need to write my equation. So I have y equals 7 cosine of 1 over 8 over pi x minus 3 plus 3. And that's it. Do the best you can with worksheet 5. I know it can be challenging in places. We'll definitely take questions on that when the next time we see you in class. So just do the best you can. If you can only do parts of it and you get stuck, that's okay. Do the parts that you're okay with, finding the K's or the H's or the C's or whatever you're most comfortable with. Do those parts, and then we can talk about places where you get stuck or you have questions when we meet back next time. Okay? And you might want to be ready for a homework quiz the next time we meet. Okay, bye-bye.